This tutorial is another force problem in which the forces are not in equilibrium, so they do not balance out. We still start the same way. We read the problem during recent World's Strongest Man competition. Phil Pfister pulled a bus with a mass of 6,400 kilograms. The average coefficient of kinetic friction between the bus and the other parts is estimated as 0.25. If Phil pulls with a force of 24,500 newtons at an angle of 15 degrees above the horizontal, what is the acceleration of the bus? We start by drawing that free body diagram, and we're on the Earth, so there is a gravitational force. We're on a surface, so there's both a normal force and a frictional force. Now, if the bus is being pulled to the right, which I will assume it is, then the frictional force is to the left. And it's kinetic friction because it is moving. There is no string, rope, or cable, but we're going to consider Phil's pull to be an applied force, which is at a 15-degree angle. Next, we write down our givens. The mass is 6,400 kilograms. The coefficient of kinetic friction is 0.25. The applied force is 24,500. And we need to find what is the acceleration. Just as before, if we're given the mass, first step is going to be solving for the gravitational force, which is mass times gravitational field. So we have 6,400 kilograms times 9.81 newtons for every kilogram. And we get that the gravitational force of our bus comes out to be 62,784 newtons. The next step is we have this applied force at an angle. So I'm going to redraw this over here. 24,500 at a 15-degree angle. We're going to solve for its its parallel and perpendicular components. Let's solve for that parallel component first. Because it is the adjacent side, we say that the parallel component is going to be the hypotenuse times the cosine of our 15 degrees. And we get the parallel component comes out to be 23,665 newtons. Then we're going to solve for the perpendicular component. That is the opposite side, so we'll use the sine in this case. And we get the perpendicular component to be 6,341. And the units would be newtons. So let me draw those in here, perpendicular and parallel components. And again, what we're doing is we're replacing this applied force with its two parts. We're replacing it with the parallel and perpendicular component. Now, we are not in equilibrium. So we can't go to the sum of the force in the x equals 0 and the sum of the force in the y equals 0. Well, we do see those that to find the acceleration, if we just think about it, the acceleration is in the x direction. It's going to accelerate to the right. The bus is not accelerating up or down. In fact, it's not moving up or down. So the up and down forces still balance out. It's the left and right forces that are unbalanced because that's the direction of the acceleration. Because it accelerates to the right, we expect parallel force to be more than the kinetic friction force. So when we go to our two equations, the total force in the x direction is not balanced out. So the total is mass times acceleration. However, the forces still balance out in the y direction, so they still add up to 0. Our main objective is to find this acceleration. So let's start there. If we look at our forces in the x direction, we have the parallel to the right and the friction to the left. And so we have the parallel component is positive, the friction is negative, and that's equal to mass times the acceleration. Now, in order to solve for that acceleration, I need to know the mass, which I do, the parallel component, which I do, and the friction, which I unfortunately do not. So how do we get the friction? Well, let's turn to the y direction. In the y direction, we have three forces, the normal, which is up, the perpendicular force component, which is up, and the gravitation, which is down. So if I come back in here and I put the normal force up, the perpendicular component, which is up, and the gravitational force, which is down, they total to 0. I know the perpendicular force and the gravitation, so I can solve for the normal force. Gravitational force was 62,784. I get the normal force, and that comes out to be 56,443 newtons. That still, unfortunately, does not tell me the kinetic friction. But there is a relationship between the normal force and the kinetic friction, and there it is. And I know the coefficient, and I just solve for the normal force, so now I can solve for that kinetic friction. Remember that coefficient is 0.25. So 0.25 times 56,443. We get the friction comes out to be 14,111 newtons. So now we know the friction, and that was the last piece in order to get the acceleration. So the parallel component is 23,665. The friction is 14,111. The mass is 6,400 kilograms, and we need to find the acceleration. We solve and we get the acceleration to be 1.49 meters per second squared.